Hi, welcome to part 3 of the Urban Ecology series. My name is Jean, and today we're going to focus on understanding urban soils. First off, I want to say thank you to the Public Library Innovation Exchange at MIT, who develops STEAM learning activities for public libraries. A special thank you to the PLIX team, Avery, Lydia, Catherine, and Philip. I also want to thank Priyata Lane and Associates for sponsoring the Urban Ecology Kits available at the library. If you haven't had a chance to pick up a kit, just give us a call at 781-324-0218 to reserve yours. This is part 3. If you haven't had a chance, make sure that you go back and check out the Sensory Nature Walk and Tangible Ecosystem videos for other activities, which are a good foundation for this third activity. Today, we're going to focus on the diverse functions and roles of soils and also learn how to categorize various soils and the species therein, and learn how to unravel urban environments with their soil structure and function. Here's a look at your Urban Ecology Kit. Today, we'll be using the field journal, the third zine for soils, plastic bags, tracing paper, jar, and shovel. And you probably also want to use your magnifying glass. All right, so you want to go out and find your soil samples. You can do this in a lot of different places, all different environments. It doesn't have to be in a wooded foresty area or anywhere rural. You can do this right in your yard. You can do it alongside the road. We want a variety of soil samples. Collect from multiple sites if you want to contrast the different type of samples that you have. So I recommend at least 2 different sites. And you might want to vary the sites considerably. So if one is in a more industrial area and one is in a more rural area or forested area, you might have a more interesting contrast for this exercise. When you are collecting your soils, there's some things to keep in mind. You want to analyze the texture of the soil. What does it feel like? You make notes in your field journal. Where did you find the soil and what did you see around the soil? So what types of plants did you see? What other features of the environment did you notice? Is there anything else that you noticed? And make sure that you document all of your findings. So write about or take pictures of the area from which you gathered your soil, and make sure you take a note of which soil is from which site. There's a few different methods for analyzing your soil sample. There are soil rubbings, clump test, and a soil shake. So we'll take a look at those 3 different methods so you can better understand your soil sample. First is soil rubbings or touch test. What you want to do is to place a few pinches of soil in a small mound on a sheet of paper. You can see in photo 1 here. Use your fingertips, rub the soil into the paper until it is separated as much as possible into its smallest components. Sand, silt, and clay have different particle sizes, so you can use this test to estimate the size of the particles present in a given sample. And we'll talk a little bit more about sand, silt, and clay in the following slides. The next is the clump test. Fill your palm with the soil sample and compress it by closing your fist. Squeeze as tightly as you can, and then open up your hand to see how well the soil sticks to itself. So the better that the soil sticks to itself, that means that there's more water in the soil. Moist soils clump easily and form a ball. Soils with smaller particle sizes tend to hold onto water more easily. So clay soils hold the most water. So clay have smaller particle sizes. Dry soils will not hold any shape. So sandy soil holds the least water. You know, if you go to the beach by the ocean and you pick up a clump full of sand, unless it's recently been hit by the ocean, you pick it up and you notice how dry it is. And in my example here, you can tell that the soil I had was quite dry. It did not clump at all. All right, here is my favorite. This is the soil shake. A soil shake, basically what you're doing is putting soil into a jar and adding water and shaking it and then seeing what happens. So try to dig down to get various layers of soil, place it in a jar, add water to the soil so that it's almost full, and then shake vigorously. But be careful when you do this, because while the lids do screw on, I find that it is best to hold the cover tight onto the jar to make sure that while you're shaking vigorously, the cover doesn't come off and you end up with dirt everywhere. So once you have shaken your soil sample in water, put the jar somewhere where it will not be disturbed for 48 hours. Here you can see I have the dry soil before I added the water. And then right after I added water, it already starts settling down. And then the next picture is about 24 hours later, things are moving around. And finally, the fourth one you can see is with different layers. And you can see how some particles are a different color and have risen towards the top. That's the middle silt layer. The bottom is sandier and the top is clay. Here's how you read your soil jar. So you will notice that sometimes with your soil there's various organic matter, sticks, roots, things like that. Those things will float to the top, and then there might be a bit of a gap, and you'll see your top layer is clay, your middle layer is silt, and your bottom layer is sand. And if you look here, you can see the different structure and size of the particles in your sample. And what you want to do is estimate approximately what percentage of your soil is each type of soil. So in this example, 20% on the top is clay, 50% is silt, and 30% is sand. And you want to keep those numbers in mind, write them down in your journal, and then here, use this soil triangle to figure out where your soil lies, and you can make a general assumption of what type of soil you have. So clay, very rich in nutrients. It's heavy, waterlogged. A lot of plants don't grow in clay, but some thrive, like the weeping willow. And then loam is a mixture of sand, clay, and organic matter, which is ideal soil for most plants. Sand contains large particles with lots of air pockets, very little water retention, and it's good for plants that thrive in dry climates like roses. Finally, silt is soft, smooth, and very fertile, holds moisture well, and is great for plants that love damp conditions like ostrich ferns. So if you look at this triangle, what you want to do is mark where your percentages are. So there's 3 different vertices. So clay, there's a percentage. If you had 20% clay, you would mark that closer to the bottom. And then sand, if it's about 50% sand, you'd mark it in the middle. And then silt is about 30%, and you're marking it from the top, so it'll be closer to the top. And then you find where those points intersect, and then find exactly what type of soil that you have. And it's important to figure out what type of soil you have to understand its role in the environment. You know, what types of plants does it support, and what's its function, and what works best in that environment. So some plants might not be able to grow in that type of soil, and some will thrive and some will grow but not well. Now, why are soils so important? Soils have many functions. There are 6 of them listed here. Big one is filters. Soil grabs pollutants from storm water, removing impurities before going underground. They also are recyclers, transforming decomposing material into organic matter, They act as habitats for many micro and macroorganisms, so home for many creatures. Foundation, they serve as scaffolds for many types of built features. So dirt will help support buildings and sewers, various other things. They act as sinks, removing and storing atmospheric gases, helping to reduce the effects of climate change. So soil is not dense. There's space, in the soil for air and gases. They act as regulators. Soils regulate moisture between storm events, absorbing and storing water for later use. So if it rains, we don't have a huge flood every single time. You'll notice the difference between when water falls on soil versus falling on roads or concrete, rather than just having the water slide down the concrete. For soil, it absorbs the water to an extent, and that prevents flooding. Well, I hope that you enjoyed learning about dirt and soil today, and that you find these activities fun. Be sure to wash your hands when you're done. And if you have any questions about this activity or any of the urban ecology activities, or you have any feedback, I'd love to hear about it. You can call me at the library at 781-324-0218 or email me. And I'd love to hear your feedback. This is the first time that we have done one of the MIT Public Library Innovation Exchange programs. So I'd love to hear what you liked about it, what you think could be improved, and if we held more of these types of programs and STEAM programs, if you would be interested in attending. Thank you so much and enjoy.